Hello guys, how are you? Welcome to Cosmic Essence Education. My name is Maitray and this is the second part of the video where we'll be covering types of functions. Okay, so now we covered 4 types of functions in the first video. Those were identity function, constant function, polynomial function and rational function. In this video we'll be starting with the modulus function. Modulus function, which is also known as the absolute value function. So let us define a function f from set R to R such that set R means the set of real numbers, such that y is equal to mod x, which is also equal to the square root function, which is root of x square. So both are the same thing. This is how we represent modulus function. This is the square root function. Both are equal to one another for all values of x belonging to R. Now what does modulus x mean? Now modulus x is the modulus function. It means that for a real number x, mod of that number will be the distance of that number from 0 on the number line. For example, say I want to write the modulus of minus 5. Modulus of minus 5 would mean the distance of minus 5 from the 0 on the number line. From 0 on the number line. So the distance of minus 5 from 0 is this distance, which is equal to 5. If I want to write the modulus of 5, that is also 5 units from the 0 on the number line. So the distance here is also 5 units. So the modulus of both minus 5 and 5, which tells us the distance from 0 on the number line, is both 5. So using this information, I can define what modulus x means. Modulus x is equal to x for x greater than or equal to 0. Whenever x is positive or equal to 0, x will be equal to x itself. It will come out as x itself. For x less than 0, when x is less than 0, that means it is negative, it will come out with a negative sign. Why? Because negative sign of a negative number will in total give us a positive quantity, which is what we mean by the absolute value. Alright, so it is always positive. That's why we put a negative sign here if x is less than 0. This is how we define the modulus function. Let's look at the graph of mod x. Now, for positive values of x, y is equal to x. Let's write it down here. And for negative values of x, it is equal to minus x. So, for x greater than or equal to 0, we will make the graph of y is equal to x, which is this line. But we will be only taking those values which are 0 or positive. We will not be considering this part of the line. For x less than 0, y is equal to minus x. So y is equal to minus x, the line will be like this. We will not be considering this part because we are talking about negative numbers. So the solid line that I have made here, this is the graph of mod x. Now we can easily tell the range of this function. Of course, the domain of this function is the set of real numbers, and the range we can tell from the graph. The value of y is varying from 0 up till plus infinity. So the range is closed interval 0 to infinity, which can also be written as y is greater than or equal to 0. This is the modulus function. Okay, so the next type of function is the signum function. The signum function. Let us define a function f from R to R such that y is equal to, now it is a breakwise function, so we will divide it into two parts. Mod x upon x when x is not equal to 0 and 0 when x is equal to 0. This is the signum function. If we write it down further, let's look at this. When x is not equal to 0, this is the definition. So if I take the interval x is greater than 0, if I take it x is greater than 0, in that case mod x will be written as x and x is here in the denominator, so x upon x will be equal to 1. If I take the interval x is equal to 0, in that case the definition is 0, and if I take the interval x is less than 0, that is when x is negative, mod x will be written as minus x upon x aa jayega, mod minus x upon x, that would mean minus 1. So this is the definition of the signum function. If I make the graph, now let's be very careful by drawing the graph. This is the origin. For all positive values of x, y was equal to 1. Okay, for positive values of x. So because we are talking about only positive values of x and not equal to 0, we will make a small circle on 0. The small circle would mean that the 1 is not included when x is equal to 0. It is not included there. And then we will make a solid line like this. So it means that for all positive values of x, the image is 1. When x is equal to exactly 0, y is also equal to 1. So the solid dot means that this is part of the graph. And when x is negative, then y is equal to minus 1. So we will again make a small circle here, which means that minus 1 is not included when x is equal to 0, and then we will make a solid line for all negative values of x. So this is the graph of the signum function. The domain is the set of real numbers, as the function is defined for all real numbers. The range of this function is only the set with elements minus 1, 0 and 1, because these are the only values of y there are. Okay, so this is the range of this function. This is our signum function. Okay, so the last type of function is the greatest integer function. Greatest integer function. Let us take a function f from R to R such that y is equal to the greatest integer of x for all values of x belonging to R. Now this is the notation for the greatest integer function. We make square brackets around x to denote greatest integer function. What greatest integer function of x is? It gives us the greatest integer less than or equal to x. That means if I talk about this interval, x is greater than or equal to 0 and less than 1. In this interval, the greatest integer less than or equal to x is always 0. Think about it. When x is between, in this interval, the greatest integer which is less than or equal to x is 0. If I talk about the interval x is greater than or equal to 1 and less than 2, the greatest integer less than or equal to x here will be 1. See that we have not put equal to signs here. The x is greater than or equal to 1 and less than 2. It is not equal to 2. That is important. So for the interval x is greater than or equal to 2, less than 3, the greatest integer will be 2. And so on, we can keep writing. Let's take the interval where x is greater than or equal to -1 and less than 0. In this interval, the greatest integer less than or equal to x. When x is -1, the greatest integer is -1. When x is between -1 and 0, the greatest integer is still -1. So in this case, it will be -1. If I continue, in the interval x is greater than or equal to 2, -2 and less than 0, the greatest integer is -2. And so on for negative values. So this is how we define the greatest integer function. If I make the graph, let's look at the graph. Now the graph of the greatest integer function is also known as the stepwise graph. It is known as the stepwise function. So let's look why it is known as that. Okay, so we were talking about intervals. In the interval where x is greater than or equal to 0 and less than 1, okay, in this interval, the greatest integer of x is 0. So we make a dot there. In the interval 1 to 2, okay, so this means that for all values from 0 to 1, y is equal to 0 like this, but it is not equal to, x is not equal to 1 here. So we make a small circle here. In the interval where x is greater than or equal to 1 and less than 2, y is equal to 1. So this is how the graph looks. Small circle here because 2 is not included. In the interval where x is greater than or equal to 2 and less than 3, y is equal to 2. So this is how it looks. And we can keep going like this on this side. Now, if we come for the negative side, when x is greater than or equal to -1 and 0, so it is in this interval, y is equal to -1. So this, we get a solid line here but a small circle at -1. Then for the interval -2 to -1, including -2, we make a solid line from -2 to here and then a small circle here. And like this, we get the graph on this side. So we can look so that this looks like we are making steps. That's why it is known as the stepwise function. Okay, let's discuss the domain and the range. The domain of greatest integer function is the set of real numbers, and the range is y belongs to the set. There, y only has integral values, so it starts from -infinity, then comes till -3, -2, -1, 0, 1, 2, 3, and so on, goes up till infinity. This is the range. That means that y belongs to the set of integers. Either we write the set of integers as I or z. This is the range of the greatest integer function. Okay, so in this video we covered a few more types of functions. I hope you liked the video. If you did, don't forget to hit the like button and subscribe to our channel, and we'll be bringing you more videos like these. Thank you.